In this problem, we're going to be asked to round our answer to 2 decimal places. We are given that an initial investment is $1,000. The annual interest rate is 8.5%, which in decimal form is 0.085. We are told that the account is continuously compounded. And so with that, remember, when you see compounded continuously, we have the A equals P e to the RT formula. Part A of this problem, and this is going to match up with the order of your homework, we're asked to find the time to double, the time it takes for the money to double. So if your money doubles, your 1,000 will have turned into 2,000. So our initial investment or the principal is $1,000. The ending amount is $2,000. E to the interest rate, which was 8.5%, but remember to use the decimal form of it, times T. Divide both sides by 1,000. 2,000 divided by 1,000 is 2. And we still have our interest rate, 8.5% times T. Now, in order to get T out of the exponent, we need to natural log both sides of this equation. Natural log is the inverse of E. So in order to cancel E, we have to natural log both sides of this equation. Because natural log and E are inverses, it knocks out the E, bringing the 0.085t down to base level. So we have natural log of 2 is equal to 0.085t. Divide both sides by 0.085. And that will isolate T. And remember, to 2 decimal places, we need, ln of 2, close parentheses, divided by 0.0085. I get 8.15 years. So a little over 8 years. Part B, we're asked to find the ending amount in the account after 10 years. So we're going to use the same A equals P times E to the RT formula. The initial investment was 1,000. E to the interest rate. This time we have a time component given, and we're asked to find the ending amount. So we have 1,000. Remember to pull up E, do second ln, and in the exponent part of it, you can either type in 0.085 times 10, or you can just type in 0.85 because that's the product of those two. Either way you want to do it. I get approximately $2,339, and my last 3 numbers are 646, so that would be 65 cents. The second problem in your homework set, find P, which is the initial investment, so that $500,000 is available for retirement in 13 years if invested at 3.5% interest compounded monthly. Okay, now remember the formula for compounding that's not continuous has a slightly different look. If it says compounded continuously, use P times e to the RT. If it's compounded any other way, well, at least not continuously, then we have this formula. R is the interest rate in decimal form, N is the number of compoundings per year, and T is the number of years the account is active. We are given $500,000 as the target ending amount. We're asked to find how much it takes in the beginning if the interest rate is 3.5%. In decimal form, that's 0.035. Compounded monthly, that's 12 times per year. And 13 years until retirement. Okay, so that's quite a bit to think about. Okay, so let's see. I'm going to tackle it from this angle. I'm going to leave P right where it is. Okay, I'm going to go to my calculator. I'm going to open a set of parentheses, 1 plus 0.035 divided by 12, close parentheses, caret, or the power button, which is right above your divide, looks like a little rooftop, and then in parentheses, because the exponent needs to be 12 times 13, I get grand total 1 point, and I'm going to keep about 6 decimal places, 5751. The more you keep here, the more accurate your answer will be at the end when you finally have to round it. Let's see. I'm going to go ahead and go with 299. There's a few extras, but that's plenty far enough. Now, if you want to keep all those, what you can do is, if you'll glance down next to your decimal point, you'll see your negative button, and on the frame right above it is ANS for previous answer. If you want to keep the entire number and use it, 500,000 divided by, if you hit second and you're negative, it'll put 500,000 slash, or the divide slash, ANS for previous answer. And when you hit enter, I get 317,434, and then 136, so that'll make 14 cents and change. And that was 500,000 divided by that long number in parentheses. On this problem, we're asked to find the missing value for the radioactive isotope. Round our answer to 2 decimal places. This appears to be a carbon-14 isotope that has a half-life of 5,715 years. We have an initial quantity of 12.5 grams, and we're trying to figure out how much would be left after 1,000 years. First, we have to find the deterioration or rate, or the value of K. Okay, so here's the equation we're going to start with. Okay, and this is basically the one for exponential growth or decay. Since this isotope will decay over time, we can expect K to be a negative value. All right, so the half-life means that half of the starting amount is equal to the starting amount times e to the k times 5,715 years. Okay, divide both sides by a. The a's will cancel. And from the previous slide, we had a way to, maybe it's a couple slides ago, but anyway, if we need an e to go away, we natural log both sides. So natural log of half equals natural log of e to the 5,715k. ln and e will cancel. Natural log of half equals our exponent. And therefore our deterioration or rate of decay is natural log of 1/2 over 5,715. Now that's part 1. Now we're looking for the amount at the end when we start with 12.5 grams. We now have the rate of decay. If you want to leave that as ln half over 5715, that's totally fine. If you want to get you a decimal version of that, natural log of 1/2, close parentheses, divided by 5715, and sure enough it's negative. And if you prefer to use the decimal form, that's fine. Now hang on to several decimal places though, so we have negative 0.3 zeros and a 121. Alright, so we'll carry that value up here. Let me clean this up just a tad. My handwriting's atrocious, but hopefully we can follow along. Alright, so we've got the k value is negative 123,121 times 1,000 we had to figure out how fast this thing decays before we can determine a final amount. So that was the first part of this, was finding k, the deterioration rate. Let's see, 12.5 second ln to bring up e, negative, and then we put all that in the exponent, negative 0.3 zeros, 121 times 1,000. All right, and I get 11.08 because I've got 0.075. Grams remaining after 1,000 years. So it doesn't deteriorate very fast, but it does deteriorate. The number of bacteria in a culture is increasing according to the law of exponential growth. After 3 hours, there are 200 bacteria. After 5 hours, there are 800 bacteria. How many bacteria will there be after 6 hours? Okay. Our first line of information, we have 50 bacteria we don't know the initial amount, e to the k times 2 The 2 can go in for T because it was 2 hours. Okay, so solving for A is equal to 50 divided by e to the 2k. The second line of information, after 5 hours there are 400 bacteria, allows us to write this one. 400 equals, we don't know A, but we have A solved in that step. So I'm going to put 50 over e to the 2k in here. And then our time, 5 hours, will be e to the 5k. Reducing, we get 400 equals 50 e to the 2k reduces 5k to 3k. $400 divided by 50, that's 8 equals e to the 3k. Natural log of 8 equals natural log of e to the 3k. And so, remember, those will cancel. Natural log of 8 is equal to 3k. Natural log of 8 all over 3. Be careful not to write that as 8/3. That's natural log of 8 all over 3. Gives us our growth factor. So now we can go back let's find A. A is equal to 50 divided by e to the 2k, e to the 2, and then we just found k to be natural log of 8 over 3. Natural log of 8 over 3. Let's see what A comes out to. A is going to be the initial amount of bacteria. Let's see. You got to be very careful entering this one. It might be smart to do second ln, bring up your E. 2 times natural log 8, close parentheses, divided by 3. Make sure all that's in your exponent. Get that answer, which I get 4. And then 50 divided by 4 is 12.5. I'm going to recalculate that just to be sure. 50 divided by e to the 2 times natural log 8, close parentheses, divided by 3. All that has to be the exponent of e. Yep, 12.5 works out. Now to answer our final question, we know K, we know A. How many bacteria will there be after 6 hours? I'm going to do this in red. That part. (12.5) e to the k times 6 Okay, so that's y equals 12.5 e, that's a 2, to the 2 times natural log of 8. Okay, so just be careful typing it in. 12.5 second ln 2 ln 8. Make sure 2 ln 8 is the power of e, and hit enter, and I get 800 bacteria. That's a doozy of a problem. So hopefully between this video and the video on your WebAssign problem, we can lay at least a decent foundation of how to set these up. But what I would recommend is take each line of information, find K, then find A, and then once you know K and A, you can plug these values in here and here to get your overall value of 800 for this particular problem.